Hey guys, good evening, and welcome back again to your Unacademy NEET English channel. I hope all of you are doing great, having a good time. So, my dear students, quickly let me know in the chats if all of you can hear me, if I'm perfectly audible, visible to every one of you. Let me know quickly in the chats with some fire emojis. If all of you can hear me, if I'm perfectly audible, visible to every one of you. Good evening, people. Good evening, and welcome back. Good evening and welcome back. Good evening and welcome back. So, am I perfectly audible, visible to everyone? Yes? Let me know in the chats, people. I know a lot of you are asking about the actual plan of this particular series, right? Tomorrow in the evening, or maybe day after tomorrow, right? I'll be sharing a video with all of you wherein I'll be giving you the complete plan of this particular series, right? When your syllabus will end, how we are going to complete it, how many sessions for what all chapters. That is something which I'll be sharing with all of you maybe tomorrow or day after tomorrow. Okay? Yeah? Is that cool? Don't worry about that. Don't worry about that. I'll be sharing that with all of you. Perfect. Should we start, people? All ready? Should we start the session? And before starting the session, can you let me know in the chats like how many of you have watched the first session of the mole concept, which I took like 3-4 days back? Just say yes or no in the chats. Thank you, Muzamil. Thank you so much. Shayan Banerjee, you can definitely take it. Okay, I can see majority of the students have already joined the first session of the mole concept, right? Perfect. All right, so my dear students, today it's going to be the second session, the lecture number 2 of the chapter mole concept. Okay, of the chapter mole concept. This is going to be lecture number 2 of your chapter, that is the mole concept. Perfect. Hello, Farheen. Hello. How are you? All right, people. So let's get going then. Let's get started. And the topic with which we are going to start today, what is that going to be? That is going to be one of the important topics from which you get questions many a times, whether you talk about your NEET examination or even your JEE examination. Okay? What is that topic exactly? That is average atomic mass. That is average atomic mass of an isotopic mixture. Average atomic mass of an isotopic mixture, which I'm representing with MAV. Average atomic mass of an isotopic mixture, which I'm representing with MAV. Okay? Well, before going into the details of this particular topic, there are some basic things which you must know. Okay, what are those basic things? That is the definition of isotopes. How do we exactly define the term isotopes? How do we define the term isotopes? My dear students, isotopes are nothing but, I would say isotopes are the atoms. Isotopes are the atoms of same element. Isotopes are the atoms of same element having same atomic number, but different mass numbers. Isotopes are defined as, isotopes are the atoms of same element. These are the atoms of same element, having same atomic number but different mass numbers. What is meant by that? Let's try to understand first. For example, you talk about the element hydrogen. You talk about the element hydrogen. I'm pretty much sure all of you must be knowing, when we talk about hydrogen, hydrogen has got 3 atoms. Hydrogen has got 3 atoms, which have got same atomic number. Hydrogen has got 3 atoms, which have got same atomic number, but their mass numbers are different. Their mass numbers are different. So can I say these are the atoms of same element, having same atomic number, but different mass numbers? Absolutely. Should I be calling these 3 atoms as the isotopes of hydrogen? Absolutely, I'll be calling them as the isotopes of hydrogen. As simple as that. Number 1. If I talk about, for example, chlorine. If I talk about chlorine, as you all must be knowing, this chlorine again it has got 2 atoms. Again, it has got 2 atoms, which have got same atomic number, but different mass numbers, 35 and 37. So, my dear students, these are again the atoms of same element, which have got same atomic number, but different mass numbers. So, again, I'll be calling them as the isotopes. So, these 2 atoms are nothing but isotopes of chlorine. Perfect. In the similar way, for example, I have got an element X. Let's say I've got an element X. I'm assuming that this X has got 2 atoms. This element X has got 2 atoms, which have got same atomic number, represented by Z, but their mass numbers are different, M1 and M2. So what do I call these 2 atoms as? I'll be calling these 2 atoms as the isotopes of X. I'll be calling these 2 atoms as the isotopes of X. Perfect. Now, my dear students, after understanding the meaning of isotopes, let me tell you one important thing. My dear students, whenever you see an element having isotopes, for that particular element which has got the isotopes, for that particular element, what do we define? We define average atomic mass. For that particular element, we define average atomic mass, right? So, my dear students, whenever you see an element having the isotopes, that particular element which has got the isotopes, for that element, what do we define? We define average atomic mass. Now, people, in order to calculate the average atomic mass, what do we exactly need? In order to calculate the average atomic mass of an element which has got isotopes, what do we exactly need? My dear students, we need something called as percentage abundances. We need something called as percentage abundances of the isotopes. What is meant by the percentage abundance? You'll be getting the idea about that in like 5 to 10 minutes. Right now, remember what I'm saying. Whenever you see an element having isotopes, for that particular element which has got isotopes, what do we define? We define average atomic mass. In order to calculate average atomic mass, what do we need? We need percentage abundances of the isotopes. And my dear students, percentage abundances of the isotopes are represented by A% and B% respectively. What is this A%, B%? You'll get the idea in 5 to 10 minutes. Again, I'm telling you, right? Now, my dear students, if you get the percentage abundances of the isotopes, you can make one formula. And formula is pretty much simple. Formula is going to be M1 multiplied by A. M1 multiplied by A plus M2 multiplied by B divided by A plus B. This becomes my general formula. This becomes my general formula to calculate the average atomic mass of an element which has got the isotopes. Right? Now let's try to understand this a bit more in detail. Have a look, people, what I'm going to say. For example, take an element chlorine. As you all must be knowing, how many isotopes chlorine has? I would say chlorine has 2 isotopes, which have got same atomic number, but their mass numbers are different, 35 and 37. As I told you, people, Whenever you see an element having isotopes, what do we define for that element? We define average atomic mass. In order to calculate average atomic mass, what do we exactly need? We need the percentage abundances of the isotopes. And let me tell you, the percentage abundances of these isotopes are equal to 75% and 75% and 25% respectively. Now, what is meant by this 75% and 25%? Let's try to understand. My dear students, imagine that chlorine has got two isotopes, Cl35 and Cl37. I am telling you that the percentage abundance of this isotope is 75% and the percentage abundance of this isotope is 25%. What does it mean? It means that out of all the chlorine present in the nature, I would say 75% of the chlorine atoms will be existing in the form of Cl35 and the remaining 25% of the chlorine atoms will be existing in the form of Cl37. Or just understand it like this. For example, the room in which I am taking the lecture right now. Imagine that in this room, there are total 100 chlorine atoms. Imagine that in this particular room, there are in total 100 chlorine atoms. Now people, it's pretty much simple. Out of those 100 chlorine atoms, there will be some chlorine atoms which will be Cl35. There will be some chlorine atoms which will be Cl37. And this percentage abundance is telling me that out of all the 100 chlorine atoms, 75 chlorine atoms will be Cl35 ones and the remaining 25 chlorine atoms will be Cl37 ones. Okay? I believe you got the meaning of the percentage abundances. Am I clear with this? Tell me once in the chats quick. Again, I'm telling you, imagine that in this room, there are in total 100 chlorine atoms. Out of 100 chlorine atoms, you will find 75 chlorine atoms. Which ones? Cl35 ones. Remaining 25 chlorine atoms, you'll be finding which ones? Those are going to be Cl37 ones. Okay? I believe this is clear. Now, my dear students, since you got the percentage abundances of the isotopes, so these percentage abundances, we represent with A and B respectively. You know that already. This is something which you call as M1. This is something which you call as M2. Perfect. Now, what is the formula to calculate M average? M average is nothing but it is M1A plus M2B divided by A plus B. This is the formula. Now, what is the value of M1? M1 is simply 35. What is the value of A? A is 75. What is the value of M2? 37. What is the value of B? B is 25. A plus B will directly come out to be 100. And when you solve this equation, you get the value exactly as 35.5 AMU. So what is this 35.5 AMU? Is it the normal atomic mass of chlorine? No. This is something which I call as the average atomic mass of chlorine. So my dear students, average atomic mass of chlorine comes out to be 35.5 AMU. Am I clear with this? Number one, point number one. Now people, point number two. Try to understand very carefully what I'm going to say. Point number two. See, first of all, this A plus B, 75 plus 25, it came out to be what? It came out to be 100. A plus B, 75 plus 25, it comes out to be 100. So remember one more simple thing. Remember, my dear students, the sum of percentage abundances. The sum of percentage abundances of all the isotopes. The sum of percentage abundances of all the isotopes of a particular element. The sum of the percentage abundances of all the isotopes of a particular element. That means I'm talking about A plus B plus C plus dash dash dash. It's always equal to what? It's always equal to 100. Remember this particular point as well. Yeah? Am I clear? Am I clear with this, people? Remember this particular point as well. Okay? One more important thing. Is the atomic mass coming out to be fractional here? If you look carefully, there is a decimal, 35.5. The atomic mass is coming out to be fraction. It is coming out to be fractional. My dear students, whenever you see an element whose atomic mass will be in fraction, remember, that is not going to be the normal atomic mass of an element. That's going to be the average atomic mass of an element. That's going to be the average atomic mass of an element. Remember this particular point as well. Okay? Perfect. Now, people, so if we got to know that A plus B plus C plus D is always equal to 100, if you got to know that, then what we can do here, we can modify this particular formula and we can write it like this. MAV is nothing but M1A plus M2B divided by, instead of A plus B, we'll be directly writing, perfect. Instead of A plus B, we'll be directly writing 100. I believe this is clear. Now, my dear students, try to understand one more thing which I'll be telling you right now. Look. Remember, people, whenever percentage abundance of an isotope is divided with 100, whenever percentage abundance of an isotope is divided with 100, for example, I divided A with 100. Similarly, for example, I'm going to divide B with 100. Now, this A by 100 or this B by 100, now you are not going to call them as the percentage abundances. You will be calling them as the fractional abundances. You'll be calling them as the fractional abundances. When percentage abundances are divided with 100, what do we get exactly? We get fractional abundances. So, people, now you can make one more simple formula here. MAV is equal. This 100 is the denominator of this term as well as this term. So, I can write M1A by 100 plus M2B by 100. I can write it separately. Now, people, the formula becomes MAV is equal to M1 multiplied by, what is A by 100? A by 100 I'm calling as fractional abundance of first isotope plus M2 multiplied by fractional abundance of second isotope. This becomes one more result, one more formula which we have to calculate the average atomic mass of an isotope. Sorry, average atomic mass of an element which has got isotopes. Perfectly done? Perfectly done, people? So, one of the formula is in terms of percentage abundance. One more formula is in terms of what? Is in terms of fractional abundance. If I'm clear, let me know once in the chats quickly, people. Quickly, I would want to know from everyone. Quickly in the chats. Is it clear? Yeah? See, the sum of percentage abundances is the sum of percentage abundances of all the isotopes of a particular element. That's always equal to 100. And I can say the sum of fractional abundances of all the isotopes. The sum of fractional abundances of all the isotopes of a particular element. Is equal to 1. Remember this particular point as well. Right? What if there are 3 isotopes? I'll be coming to that as well. Just give me some time. Perfectly done. Now, my dear students, before solving the questions based on the same concept, there are a few more things which I would want to tell you. What is that? Let's say you have got an element X. This X has, for example, 3 isotopes, right? This X has got 3 isotopes, which have got same atomic number, but their atomic mass are different. This is M1, this is M2, and this is M3. Perfect. Now, if the element has isotopes, we calculate average atomic mass for that element. And in order to calculate average atomic mass, what do we need? We need the percentage abundance of the isotopes. Percentage abundances I'm representing with A%, B%, and C%, right? Now the formula is modified a bit. The formula is going to be M1A plus M2B plus M3C divided by A plus B plus C, that's always equal to 100, as I told you already. Right? As I told you already. Perfect. Perfect. Now, people, for example, I'm giving you one simple question. I would want you guys to give it a try. Let's say you have got an element boron. You have got an element boron. For example, this boron has two isotopes. One is B10, one is B11. Boron has got two isotopes, B10 and B11, right? I'm giving you the percentage abundance of the first isotope. Percentage abundance of the first isotope is 19%. I'm asking you to calculate the average atomic mass of boron. Can you give it a try and let me know the answer? Can you give it a try and let me know the answer quick? Everybody? Can you give it a try and let me know the answer quick? Everyone. Let me know quick, people. Is it done? Exactly. It's 10.81 is the correct answer. So it's a pretty simple question, guys. I'm pretty much sure you would have easily killed this question. See, if the percentage abundance of the first isotope is 19%, that means the percentage abundance of the second isotope has to be 81%, because the sum of percentage abundances has to be equal to 100. So 19 plus 81 is nothing but 100, right? So people, this is something which I call as the value of A. This is the value of B. This is the value of M1, and this is the value of M2. So M average is nothing but, it is going to be equal to M1A plus M2B divided by A plus B, that's always equal to 100. M1 value is given to me as per the question, that's 10, multiplied by A value is how much? 19, plus M2 is 11, B is 81, divided by A plus B is 100. When you solve this, the value comes out to be 10.81 AMU. So what is this 10.81 AMU? It is the average atomic mass of boron, which I was supposed to calculate. I believe this sort of a question is again clear to every one of you. Okay. Now, let me slightly modify the question. Let me slightly modify the question. For example, I'm giving the question like this. You have got an element X. You have got an element X. My dear students, imagine that this X has got two isotopes. One is X35, one is X37. Okay. Let's say the average atomic mass of this X, the average atomic mass of this X is 35.5 AMU. I'm asking you to calculate the percentage abundances of these isotopes. I'm asking you to calculate the percentage abundances of these two isotopes. Can you give this question a try? What do you think? Will you be able to solve this? Say yes or no. Answer you can easily guess, 75-25, but I want you to solve it and then get the answer. Because you already know the element has to be chlorine, right? The element has to be chlorine, and its percentage abundance are 75-85. You know that. Yeah? Thank you, Wassim. Perfect. So let's give this question a try. See guys, it's a pretty simple question. As far as the question is concerned, as you can see properly, this element has got two isotopes. Perfect. Now, my dear students, we know one thing. the sum of percentage abundances of these two isotopes, the sum of percentage abundances of these two isotopes is equal to 100, is equal to 100, right? Let's assume that the percentage abundance of the first isotope is, for example, X%. Therefore, the percentage abundance of second isotope has to be 100 minus X%. Simple, right? Perfect. And these percentage abundance are nothing but, these are the values of A and B. This is the value of your M1 and this is the value of your M2. Now, M average is 35.5 is equal to M1A plus M2B divided by A plus B, that's 100, right? So it is going to be 35.5 is equal to, what is the value of M1? That is 35. What is the value of A? That's X. What is the value of M2? 37. What is the value of B? 100 minus X divided by A plus B is how much? A plus B is 100. Now do the cross multiplication stuff and you'll be getting the value of X exactly as how much? X value, you'll be getting exactly as 75%. And what was X? X was the percentage abundance of this particular isotope, right? Similarly, what is going to be the percentage abundance of this isotope then? X37, that's 100 minus X. That's 100 minus X. 100 minus 75 is nothing but 25%. Am I clear with this? Am I clear with this? Yes or no in the chats? Yeah? Perfect, guys. All right. One more question I'm giving you. Let me see if you can solve that or not. For example, you have got a question like this. Let's say you have got the element magnesium. Let's say you have got the element magnesium. I'm telling you that magnesium has got three isotopes. One is Mg24, Mg25, Mg26. These are the three isotopes of magnesium. These are the three isotopes of magnesium, right? Now, my dear students, the percentage abundance of first isotope is 79%. And the average atomic mass of magnesium is given to me as 24.31. I am asking you to calculate the percentage abundances of these two isotopes. Can you give it a try? Sir, I got centum in chemistry of class 11th because of you. Thank you so much. My chemistry ma'am said I was of no use because I was scoring average marks, but now she believed in me. Thank you. That's great. Glad to know that. Amazing. Can you give this question a try, everybody? Can you give this question a try, everybody? It's a simple basic question. It's not difficult at all. It's a simple one. It is a simple one. It is just a bit of calculation would be involved in the question. Elise, what I'll be doing tomorrow or day after tomorrow, I'll be posting a video, a detailed video, in which I'll let you know in how many days your syllabus and stuff will get completed. Don't worry. Okay? Do watch that particular video. All right, let's have a look exactly how we are going to solve this particular question. Try to understand very clearly, guys. It's a simple question only. See. First of all, this magnesium has got three isotopes, right? Well, the sum of percentage abundances of these three isotopes, the sum of percentage abundance of these three isotopes is equal to 100, right? Now, out of 100, the percentage abundance of the first one is 79%. out of 100. The percentage abundance of the first isotope is 79%. So how much is remaining? 100 minus 79. That comes out to be 21%. So 21% is the percentage abundance of these two isotopes. 21% is the percentage abundance of these two isotopes, right? So I would say percentage abundance of this plus the percentage abundance of this one. It is equal to 21. Now out of that 21, let the percentage abundance of Mg25 is X. So therefore, the percentage abundance of this one is simply going to be 21 minus X%. Am I clear with this particular point? Say yes or no in the chats, everybody. Say yes or no in the chats quick. Is this particular step clear to everyone? Is this particular stuff clear to everyone? Yeah? Now, we are almost done. Have a look properly. These percentage abundances we represent with A, B and C, right? This is the value of your M1, this is the value of your M2 and this is the value of your M3. Now, my dear students, M average is 24.31 is equal. It's going to be M1A plus M2B plus M3C divided by A plus B plus C, that's 100. So 24.31 is equal. What is the value of M1? That is 24, right? What is the value of A? That is 79. What is the value of M2? 25. B value, X. M3, that is 26. C value, 21 minus X. Divided by what? Divided by 100. So do you see you got one equation having one variable only? Right? Do you see we got one equation having one variable only? That's X, right? My dear students, when you cross multiple stuff, you'll be getting the value of X exactly as 11%. And what was this X? X was the percentage abundance of Mg25. Therefore, percentage abundance of Mg26 is going to be 21 minus X. So it's going to be 21 minus 11. The value comes out to be 10%. Am I clear with this particular question as well? Quickly in the chats. Is it clear, people? Is it clear? Let me know in the chats quick. Everybody. Yeah? Perfect. One more similar question I'm giving you. Let me see if you can solve that or not. For example, you have got the question like this. The element is iron. The element is iron. Let's say iron has got three isotopes. Let's say iron has got three isotopes. Fe54, Fe56, Fe57. These are the three isotopes of iron. Okay? These are the three isotopes of iron. Now, my dear students, for example, the average atomic mass of iron is given to me as per the question, which is 55.95 AMU. 55.95 AMU. And at the same time, the percentage abundance of the first isotope is, for example, 5%. It is 5%. I am asking you to calculate the percentage abundances of these two isotopes. I'm asking you to calculate the percentage abundance of these two isotopes. Can you give it a try? Can you give it a try, people? Quick in the chats. The English channel. It kya kar bu kashir podcast. Check it out, people, quick. It is a similar sort of question. It's a similar sort of question, people. Let me give it a try. Let me give it a try. And let's see how this sort of a question is to be solved. Let's see how this sort of a question is to be solved. Have a look. First of all, the abundance of first isotope is 5%. So how much is remaining? Since you know already, the sum of percentage abundances of these three isotopes has to be 100. Now, out of 100, the percentage abundance of the first one is 5%. So 95% is remaining. Out of that 90%, let the percentage abundance of this isotope is X. So this has to be 95 minus X. Yes. Now, this is the value of your M1. This is the value of your M2. And this is the value of your M3. This is the value of your A. This is the value of your B. And this is the value of your C. Perfect. Now, people, we are almost done. Instead of M average, what can I write? I can write 55.95 is equal to M1A plus M2B plus M3C divided by A plus B plus C. That's always equal to 100. So it's going to be 55.95 is equal to, what is the value of M1? That's 54. What is the value of A? A is 5. M2 value, 56. B value, X. M3 value, 57. C value, that's 95 minus X. Divided by A plus B plus C, that's 100. And when you do the cross multiplication and stuff, you'll be getting the value of X exactly as 90%. And what was this X? I would say X was nothing but it was the abundance of Fe56. Therefore, what is going to be the abundance of Fe57? It is 95 minus X. So, which comes out to be 95 minus 90. The value comes out to be 5%. I would say these were the two things which I was supposed to calculate, right? Yeah? Is it clear, people? Is it clear to everyone? Let me know quickly in the chats. Is it clear to you? Yes, Game of NEET 2.0, that is sufficient. Yeah, you can do that. You can do that. Perfect. Now, guys, now there is one more topic which I'm going to touch right now. What is that? That's what you call as molar mass. That's what you call as molar mass. First of all, how do we exactly define the term molar mass? How do we exactly define the term molar mass? Molar mass is simply defined as the mass of 1 mole of a substance. The mass of 1 mole of a substance. Number 1. Number 2, molar mass is expressed in. Molar mass is expressed in grams per mole. Now, before understanding the meaning of this molar mass, before understanding the actual significance, actual meaning of the term molar mass, there are some basic things which I would want to share with you. What are those basic things? Have a look. My dear students, if I say 1 mole substance, if I say I've got 1 mole of substance, what does that mean? If I say I've got 1 mole of some substance, that means I have got 6.022 into 10 raised power 23 particles. I've got 6.022 into 10 raised power 23 particles of that substance which I have. What does that mean? For example, try to understand like this. Let's say I'm saying that I've got 1 mole carbon. I'm saying that I've got 1 mole carbon. What does that actually mean? That actually means I've got 6.022 into 10 raised power 23 carbon atoms. Right? Let's say I've got 1 mole of water. Let's say I've got 1 mole of water. What does that mean? That means I've got 6.022 into 10 raised power 23 water molecules. Perfect. Let's say I've got 1 mole of marker. For example, I'll say I've got 1 mole of marker. Let's say I've got 1 mole of marker. What does that mean? That means I've got 6.022 into 10 raised power 23 markers. As simple as that. Perfect. I've got 1 mole of marker. That means I've got 6.022 into 10 raised power 23 markers. As simple as that. Now people try to understand. Try to understand. There was one statement which I gave you in the last session. I hope you remember that statement. The statement was something like this. 1 AMU is equal to 1U is equal to 1D is equal to 1 by 12th of mass of carbon to atom is equal to 1.66 into 10 raised power minus 24 grams is equal to 1 divided by Na grams. Okay? This was a statement which I gave you in the last session. I hope you remember that. I hope you remember that. Now we will try to understand what exactly I'm going to say. Try to understand what exactly I'm going to say. See, first of all, how do we exactly define the term molar mass? Molar mass is nothing but mass of 1 mole of a substance. Mass of 1 mole of a substance. That means mass of 1 mole of carbon. Mass of 1 mole of carbon. Or mass of 6.022 into 10 raised power 23 carbon atoms is something which you will be calling as molar mass of carbon. Mass of 1 mole of water or mass of 6.022 into 10 raised power 23 water molecules is something which you will be calling as molar mass of water. For example, mass of 1 mole of marker. Mass of 1 mole of marker. That means mass of 6.022 into 10 raised power 23 markers is something which I'll be calling as molar mass of marker. So what is molar mass exactly? Molar mass is something which is defined as the mass of 1 mole of a substance. Or you can say the mass of 6.022 into 10 raised power 23 particles of the substance. Right? Perfect. Now guys, try to understand very properly what I'm going to say. Okay, try to understand. For example, I'm writing a statement here. I'm writing a term as molar mass of oxygen. Molar mass of oxygen. What does that mean exactly? That means I'm talking about the mass of 1 mole of oxygen. That means I'm talking about the mass of 1 mole of oxygen, right? Yeah? I'm talking about the mass of 1 mole of oxygen. What does that mean? That means I'm talking about the mass of 6.022 into 10 raised power 23 oxygen atoms. That means I'm talking about the mass of 6.022 into 10 raised power 23 oxygen atoms. Now, how can I calculate the mass of 6.022 into 10 raised power 23 oxygen atoms? How can I do that? How can I do that? You don't have to do that properly. You don't have to calculate the mass of 6.022 into 10 raised power 23 oxygen atoms. What you have to do is, you just have to calculate the mass of 1 oxygen atom. You just have to calculate the mass of 1 oxygen atom and multiply that with the Avogadro's number. As simple as that. You just have to calculate the mass of 1 oxygen atom and multiply that with the Avogadro's number. You will be getting the mass of 6.022 into 10 raised power 23 oxygen atoms. Right? Yeah? Perfect. You'll be getting the mass of 6.022 into 10 raised power 23 oxygen atoms. And whatever is going to be the mass of 6.022 into 10 raised power 23 oxygen atoms, that's what you call as the mass of 1 mole of oxygen. And the mass of 1 mole of oxygen is what you call as molar mass of oxygen. Yes? As simple as that. Now people, tell me just one thing. Tell me just one thing. What is the mass of 1 oxygen atom? You should be knowing that is 16 AMU. Multiplied by what? Multiplied by Avogadro's number. Right? Multiplied by Avogadro's number. Perfect. Now, 16 AMU. 16 I'm writing as such. Instead of AMU, can I write 1 by Na? Yes, I can do that. Instead of 1 AMU, I can write 1 by Na grams multiplied by what? Multiplied by Na. So can I say this Na gets cancelled out? The value comes out to be how much? Value comes out to be 16 grams. So what is the 16 grams exactly? The 16 grams is basically the molar mass of oxygen. The 16 grams is the mass of 1 mole of oxygen. The 16 grams is the mass of 6.022 into 10 raised power 23 oxygen atoms. Do you understand? The 16 grams is the molar mass of oxygen. The 16 grams is the mass of 1 mole of O. The 16 grams is the mass of 6.022 into 10 raised power 23 oxygen atoms. Right? Perfectly done. Now, my dear students, if you look carefully, what is the atomic mass of oxygen? Atomic mass of oxygen is 16 AMU. What is the molar mass of oxygen? It is 16 grams. Atomic mass of oxygen is 16 AMU. Molar mass of oxygen is 16 grams. So can I say, in order to convert atomic mass into molar mass, am I supposed to change the magnitude or I'm just supposed to change the units? I'm just supposed to change the units from AMU to grams, right? Talk about sodium. What is the atomic mass of sodium? Atomic mass of sodium is 23 AMU. What would be the molar mass of sodium? 23 grams. Atomic mass of nitrogen, 14 AMU. Molar mass of nitrogen is 14 grams. Atomic mass of boron, 11 AMU. Molar mass of boron, 11 grams. As simple as that, right? Am I clear with this? Am I clear with this, people? Say it in the chats quick. One more important thing. Did I take oxygen here in atomic form? Yes, I have taken oxygen in atomic form. Now, this particular term, as I told you already, either you call it as the molar mass of O, or you'll be calling this term as the gram atomic mass of oxygen. The gram atomic mass of oxygen. The gram atomic mass of oxygen. Either you call it as the molar mass of oxygen, molar mass of O, or you'll be directly calling it as the gram atomic mass of oxygen. This is one more name for it. Yeah? Perfect, people? I believe I'm clear to everyone. All right. Now there are a few more things which I would want to discuss with you. Then I can give you certain questions as well. See, guys, try to understand what exactly I'm going to say. For example, just to make you understand, here I'm writing O and here I'm writing O2. Can you spot the difference between the two? See, I would say here I have taken oxygen in which form? Here I have taken oxygen in atomic form. And here I have taken the same oxygen in which form? Here I have taken the same oxygen in molecular form. Yeah? Now, people, I'm writing few things here, which I would want you guys to remember. What are those things? Have a look. The first term, I'm writing as 16 AMU. The second term, I'm just writing 16. The third term is 16 multiplied by 1.66 into 10 raised power minus 24 grams. The fourth term, instead of 16 AMU, I'm just writing 16 grams. Yeah? Now, for this O2, the first term I'm writing as 32U. Second term, only 32. Third term, 32 multiplied by, what's happening here? Third term will be 32 multiplied by 1.66 into 10 raised power minus 24 grams. The fourth term, instead of 32U, I'm writing 32 grams. Now, I want you to tell me the meaning of all these 8 terms over here. I want you to tell me that. The first thing, which I've already discussed with you in the last session, this is what you call as atomic mass of oxygen. What does that mean? That means this is the mass of one atom of oxygen in AMU. This is the mass of one atom of oxygen in AMU. Or you can say one atom of oxygen is 16 times heavier than 1 AMU. One atom of oxygen is 16 times heavier than 1 by 12th of mass of carbon-12 atom. Right? Now, people, what was this particular term? This is what you call as a relative This is what you call as the relative atomic mass of oxygen, right? This is what you call as actual mass of O. This is what you call as actual mass of O. What does that mean? That means this is the mass of one oxygen atom in grams. Even this is the mass of one oxygen atom. This is the mass of one oxygen atom in AMU. This is the mass of one oxygen atom in grams, right? Yes. Now people, what is the 16 grams? This is what you call as the molar mass of oxygen. Molar mass of O. Or you can call it as the gram atomic mass of oxygen. Gram atomic mass of oxygen. So I would say this is basically the mass of 1 mole of O. This is the mass of 6.022 into 10 raised power 23 oxygen atoms, which is what you call as molar mass. Yeah? Perfect. Now guys, tell me the meaning of these particular terminologies which I mentioned here. This 32U, what do you call this as? You call this as the molecular mass of oxygen. Molecular mass of oxygen. Okay? That means this is the mass of one oxygen molecule. This is the mass of one oxygen molecule in you. Or I can say, one molecule of oxygen is 32 times heavier than 1U. It is 32 times heavier than 1U. What is this particular term? This is what I call as the relative molecular mass of oxygen. This is what you call as actual mass of O2. That means this is the mass of one oxygen molecule in grams. This is the mass of one oxygen molecule in grams, right? Now, my dear students, what about this particular term? This is what you call either as molar mass of O2, or you'll be calling it as the gram molecular mass of oxygen. You'll be calling it as the gram molecular mass of oxygen. That means this is the mass of 1 mole of O2. This is the mass of 6.022 into 10 raised power 23 oxygen molecules. Yes? All clear till here, people? All clear till here? Tell me once in the chats quick. Yeah? Perfectly done? Perfectly done? All right. If this is clear, there is one more thing which I would want to discuss with you. What is that? See, I'm writing one simple result. The result is pretty much simple. I'll be writing molar mass of the substance. Molar mass of the substance. Molar mass of the substance is equal to. Molar mass of the substance is equal to the mass of one particle of the substance. The mass of one particle of the substance in grams multiplied by Avogadro's number. Molar mass of the substance is nothing but it is the mass of one particle of the substance multiplied by Avogadro's number. Pretty much simple. If you know the mass of one particle, just multiply that with Avogadro's number. You will be getting the mass of 6.022 into 10 raised power 23 particles. That is something which you call as the mass of 1 mole substance. And mass of 1 mole substance is what you call as the molar mass. As simple as that. Yeah? As simple as that. I believe this is clear. And people, if this is clear, tell me the answer of one simple question. One simple question I'm giving you. For example, the question is the mass of one atom. The mass of one atom of element X is the mass of one atom of element X is the mass of one atom of element X is 2 into 10 raised power minus 23 grams. Identify the element. Identify the element. Identify the element. A simple question I'm giving you. I'm giving you some options as well. The first option is your sodium. Second option is carbon. Third option is magnesium. And last option is none. What do you think is going to be the answer of this question? What do you think is going to be the answer of this particular question? Simple and basic one this is. I want to know it from you. I want to know it from you people. What do you think? It's pretty simple question, guys. See, as you know, as far as the question is concerned, the mass of one atom of X, the mass of one atom of X is how much? It is 2 into 10 raised power minus 23 grams. If we know the mass of one atom of X, can't we calculate molar mass of X? Molar mass of X is going to be mass of one atom of X multiplied by Avogadro's number. Multiplied by Avogadro's number. So this term cancels out. The value comes out to be almost 12 grams. So this 12 grams is the molar mass of X. If you got the molar mass of X as 12 grams, so what would be the atomic mass of X? Atomic mass of X would be 12 AMU. And which element do we have with the atomic mass 12 AMU? That is going to be your carbon. Simple. Simple question, right? Similarly, my dear students, let me give you one more simple question. Let me see how conceptual clarity did you get till now. One simple question I'm giving you. Right? One simple question I'm giving you. These are the simple questions which will make your concepts like clear about these basic terminologies. For example, I'm writing a question. The molar mass of an element X is equal to 10 grams. Calculate the mass of 10 atoms of X in AMU. Calculate the mass of 10 atoms of X in AMU. What do you think? What do you think? What do you think? Quickly. Quickly, people. Guys, it's a simple question. Sairam, I'm from Srinagar, Jammu and Kashmir. Guys, it's a simple question. You are not supposed to think a lot about this. Let's show us the JEE advanced questions. First, you solve this board level question. If you are able to solve this board level question, then I'll give you the JEE advanced questions as well. Try to give the answer to this one at least. See guys, it's a pretty simple question. As far as the question is concerned, the molar mass of X is equal to 10 grams. Okay. So that means atomic mass of X will be 10 AMU. Atomic mass of X will be 10 AMU, correct? What is meant by atomic mass of X? That means the mass of one atom of X the mass of one atom of X is equal to 10 AMU. If the mass of one atom of X is equal to 10 AMU, therefore the mass of 10 atoms of X, the mass of 10 atoms of X will be 10 into 10. That's going to be 100 AMU. So the answer of this particular question is how much? It's 100 AMU. Simple. Yeah? Perfect. Okay. If this is the mass of 10 atoms of X in AMU, what would be the mass of the same 10 atoms of X in grams? This is the mass of 10 atoms of X in AMU. If I ask you what is the mass of 10 atoms of X in grams, what do you have to do? Remove this AMU and instead of AMU, write 1.66 into 10 raised power minus 24. So the answer is 100 into 1.66 into 10 raised power minus 24 grams. That is going to be the mass of 10 atoms of X in grams. Yeah? That's going to be the mass of 10 atoms of X in grams. Perfect? Perfectly done? Okay. One more question. One more question, guys. Give it a try. A simple question I'm giving you. If the value of Avogadro's number, is changed from, 6.022 into 10 raised power 23 to 6.022 into 10 raised power 20, what would be the molar mass of carbon? What would be the molar mass of carbon? Can you tell me the answer? Can you tell me the answer? It's simple, guys. Have a look. It's not difficult. See. When the Avogadro's number was 6.022 into 10 raised power 23, right? When the Avogadro's number was 6.022 into 10 raised power 23, at that point of time, I would say the mass of 6.022 into 10 raised power 23 carbon atoms. That means the mass of 1 mole of carbon would be how much? It would be 12 grams. Yes, it would be 12 grams. Now, my dear students, if the mass of these many carbon atoms is 12 grams, so the mass of one carbon atom would be? It would be 12 divided by 6.022 into 10 raised power 23 grams. Okay. Now, the mass of 6.022 into 10 raised power 20 carbon atoms would be how much? It would be 12 divided by 6.022 into 10 raised power 23 multiplied by 6.022 into 10 raised power 20. Right? This term cancelled out. The value comes out to be 12 into 10 raised power minus 3 grams. Right? So, when the Avogadro's number is changed, from 6.022 into 10 raised power 23 to 6.022 into 10 raised power 20, what is happening to molar mass? Molar mass is also changing from 12 to 12 into 10 raised power minus 3 grams. Yes. So, what can we get from this particular question? This particular question is simply telling us one thing. That when the Avogadro's number is changed, molar mass of the substance also changes. Right? So, remember this. On changing the Avogadro's number, on changing the value of Na, on changing the value of Avogadro's number, remember, molar mass of the substance also changes. Molar mass of the substance also changes. Okay? All right. One question I'm giving you as the homework. Do give that question a try. Okay? One question I'm giving you as the homework. Do give that question a try. For example, I'm giving a question like this. The question is, suppose two elements X and Y combines to form two compounds. Suppose two elements X and Y combines to form two compounds. XY2 and X3Y2. X3Y2. Full stop. .1 mole XY2. 0.1 mole XY2 weighs 10 grams. 0.1 mole XY2 weighs 10 grams and 0.05 mole X3Y2 weighs 9 grams. Weighs 9 grams. Okay, weighs 9 grams. Calculate the atomic mass of X and Y. This is your homework question. I would want the answer of this question in the comment section of this particular video. I would want the answer of this particular question in the comment section of this particular video. Okay? Perfect. And people, with this, I'll be taking a leave for today. I'll be coming up with the third session of mole concept after 3 days, right? And tomorrow or day after tomorrow, I'll come up with a plan. I'll post one video wherein I'll give you a complete plan of the complete syllabus completion on this particular channel. Okay? Perfect. Perfect. Chalo, with this I'm taking a leave. I'll see you guys tomorrow. Till then, you guys take care. And do let me know in the comment section of this particular video that how much you liked this particular session. I would check your comments personally, and do not forget to solve this question and let me know the answer of this particular question in the comment section of the video. Yeah? So with this, taking a leave, right? One more thing. The session PDF I'll be sharing on my Telegram. The name of the Telegram channel is WASSIM SIR. Wait, I'll check the name of my Telegram channel. I forgot. Just a second, people. Yeah, it is Wassim Bhat Chemistry Official. This is the name of the Telegram channel on which I keep on sharing all the PDFs and everything, right? Chalo, take a leave. I'll see you guys soon. Bye-bye. God bless you all.